Hey YouTube, welcome back. Today we have this problem called find the town judge. It says that in a town there are n people labeled from 1 to n. There is a rumor that one of these people is secretly the town judge. If the town judge exists, then the town judge trusts nobody. Everybody expect the town judge trust the town judge. There is exactly one person that satisfies these two properties, 1 and 2. So basically we have the town judge expects nobody, and everybody uh, trust him. He trusts nobody, but everyone trusts him. So basically we should know who is the town judge. For example, that we have we have two people, and we have one trust two. So basically, we have two people and one trust two, and the judge is two because I have two people, and he satisfies number two satisfies the both things, that everybody trusts him and he trusts no one, because we have one right now, only one person, so one is everybody. It is how it is. We have the second example that maybe like it's easier to understand. From the second example, we have one trust three and two trust three. So basically, both of these two trust three, but three trust no one, so the judge is three. And we have one trust three and two trust three, and three trust one. So the problem right now, everybody trusts three, but three trusts one. So three has only one condition, that everyone trusts him, but he trusts one, so he is not the judge. So the judge is -0. So how we can solve this problem is that we could build a graph, but I guess it will get too complicated. The way we could solve this problem, I guess we can just create two arrays, and for this arrays we store like we have like an in degree and out degree. For the first one, for the first array we store the the people who trust, and for the second array we store the people trust who, and we will try to find someone that satisfies both of these situations. So let's just try to code. I'll say if trust dot length less than n minus 1. That means not everybody trusts, like maybe like if we have if n equals 3, at least I expect to have two people trust one person. If it's less than that, it's just there's no need, we return false, because there is no one that being trusted from everyone. So let's just continue. It's n minus 1. We should return -1, not false. And I will say you continue const. I will call it in. There's something wrong with the code or what? Okay, const in degree equals, I will be its array, new array from n plus 1, and I'll fill it with 0. I'll fill it with 0, fill with 0, and out degree also it will be the same. So we have these two arrays, and these two arrays have the numbers of n people basically. So I will loop through the trust, and the trust is two-dimensional array. So I will loop through the trust. I'll make for of loop, const relation of trust, and I will say I have this relation, okay, and I will say the out degree, that means people who trust, they will be in out degree. I will store them, the out degree of the people who trust, okay, of a relation of 0, because people who trust are in the first position, will increase it by 1, and the in degree of people who are trusted will be increased by 1 in the in degree. So when we have this one, we'll create another loop and let I equals 0, I less than n, less than or equal n and I plus plus. Then I will say if in degree of this I, okay, of this I, because if we have 2, the people have the people are 1 2. If we have 3, the people are 1 2 3. So if this I will print I is not 0, I 1, I equals 1. So if this I equals n minus 1, okay, and the out degree of this I equals 0, we return I, otherwise return minus 1. What happened here? Okay, so let's see again and make it slowly. If n degree of I equals n minus 1, in degree, again in degree the people who are trusted, if the n degree of I equals all of the people that are trusted minus 1, for example, if we have 3 people here, if n degree equals all of the people plus 1, if n degree equals 2, and out degree of the same one is 0, this one trusts no one, but everybody trusts him that he is the judge. So let's just take an example so we can understand everything. So let's just put in degree and out degree. So equals empty array, it will be 0 0 0 and 0, 4 zeros, okay. This one's also 4 zeros. So what we're doing here, we first start with the out degree relations of I. So basically relation right now, the relation, I will say the relation equals this one in the first iteration, okay. So the relation will equals this one in the first iteration, and let's just do it like that, okay. So I'm saying that 1 trust 3, so I will save 1 in the outrage. So 1 of the index of relation of 0 will equals 1, so this one will equals 1 plus plus. So the out degree of the index of 1 will be increased by 1, so this one, it will be like that, okay. And the n degree relation 1, what is relation 1? Relation of 1 is 3, so in degree of 3 plus plus, in degree of 3, this one I will add it by 1, and I will loop again, so relation will equals the next one, 2 and 3. So I'm saying relation of 0, which is 2 plus plus, what is the relation in 0? Our degree of 0 is the second, so this one will be 1, and the in degree relation of 1, which is 3 plus plus, which we have already here, it will be 2. So we have the in degree and the out degree, and we are looping in the second loop, and we are saying if let I equals 1, and we have 3 people, so we have people number 1 and person number 2 and person number 3. So I'm saying that if in degree of I equals n, let's just minus 1, we have 3 people, and two people trust one. That means all of the people are trusting this man, and the out degree of this person is 0. He trusts nobody, so he is the judge. This is how the formula is working for this specific function. So let's just test. Okay, it's working. Let's just see why when the people that did it better than us, how they did it. They have an array, only one array, and they fill it with 0, and they have a trust record trust of I. It's two-dimensional array, I guess. No, I of 0 plus 1. I just this, but they have two loops. They have two loops. I guess they are quite similar, but just sometimes I can't read this. Just I need the time to read this. But they have two loop. I guess they are quite similar for us. I don't know how they perform better. So anyway, this is it for today's video. I hope my solution was quite good. If you like my solution, make sure to subscribe and the notification bell so you will never miss a video. And see you in future problems.